Good morning, everyone, and welcome to today's webinar, How to Improve O&M Safety and Efficiency with Remote Inspection Robots. My name is Scott Archer, Senior Director of Marketing here at Sarcos. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your desktop in the upper right corner. You're listening and use your computer speakers by default. If you would prefer to join in over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. Today's presentation is being recorded and will be available next week. I would now like to introduce today's presenter, James Dietrich, Senior Director of Sales for Sarcos Robotics. James has spent the past 6 years helping bring new robot platforms to market and has deployed robot solutions with some of the biggest retailers, healthcare providers, and service industry companies in the world. He is now bringing his expertise to heavy industry. James is a public speaker on the future of robotics and AI and is a strong advocate for augmenting human labor, not replacing humans. James, over to you.
Hey, good afternoon, everybody, and thank you again for all taking time out of your day to join this webinar and discussion. We really do appreciate it. There's well over 60 of you on so far, and presumably 60 different types of O&M challenges that each of you face regularly. So each of you play a pretty critical role in your facilities, and we're excited to share with you some tools that we know will make your operations more efficient and keep your staff safer in the process. As Scott had just mentioned, as best we can, we'd really like to engage with some of you directly during the discussion and address as many of the unique safety and efficiency challenges your teams face with O&M. So we're going to have a formal Q&A at the end. But again, our team is monitoring the webinar control panel, and we're going to be looking at questions people ask throughout the entire presentation. So again, we encourage you to use the control panel and type in a question at any time. So to kick things off, a bit of context. Sarcos has been around for about 30 years now. We've got a pretty unique history in making biologically inspired robots. We've been involved in some of these early works in prosthetics. You may have seen some of our unique projects like the Bellagio Hotel. If you've ever seen the fountains that dance, that was our project. Universal Studios, similarly, the robotic animatronic dinosaurs, that was a project we've had a heavy hand in. But most of our experience has largely been as a top recipient of DARPA funding over the past 3 decades. We've got several hundred patents and over $265 million invested in technology. And next year, we will be the first company to come out with a full-bodied, independently powered exoskeleton that can operate for 8 hours and lift up to 200 pounds repetitively. I imagine that is a webinar for another day. So let's just dive right in here. So how do we improve O&M safety and efficiency with remote inspection robots? Well, we begin by addressing the reason why proactive and preventative maintenance is so important, and that's cost. I'm not here to teach you anything new about downtime. We all know not all downtime is created equal, but I do think we can all agree that both planned and unplanned downtime in particular is realistically one of the greatest pain points for a company like yours. All of you here know better than anyone else the costs associated with planned and unplanned downtime are exorbitant, and it gets a high level of attention since equipment failures and breakdowns are highly visible. And so up until this point, your decisions on how to create safety and efficiency with your operations and maintenance has come with a premium and various cost trade-offs. There's cost towards productivity, employee safety, customer retention, other penalties, regulatory or otherwise, and supply chain distribution challenges. So again, not all downtime is equal, but the pain and impact of downtime is pretty consistent for most all industries. And so what are companies like yours doing about this problem? Well, many facilities have begun to put IoT-driven operational strategies in place to help them measure, monitor, and predict the health of their assets in real time. And this is really only possible through the advent of IoT technology enablers, such as smart sensors, digitized assets, cloud computing, and advanced science and technologies like AI and machine learning. So with all of these IoT forces aligning, more and more companies are integrating these data-centric processes into business strategies to, among other things, help minimize the cost of unplanned downtime. So when it comes to industrial maintenance, the ability to gather better asset and environmental data, analyze it, and compare it over time, this is really what's driving the shift from reactive maintenance practices to a more predictive model. So forget the IoT and other sort of data buzzwords for a moment. What this really boils down to is that some processes in your facilities will continue to be easier to automate and track than others. But at the end of the day, getting your teams the information they need when they need it boils down to making sure you and your teams have access to the right tools to gather this critical real-time data. So if gathering better asset and system data is the objective to becoming proactive in your maintenance and your plans to eliminate as much downtime as possible, well, you likely need a multi-purpose, on-demand tool that can help you gather and deliver data you need when you need it. This is where robots come in. So I always like to reference the 3 Ds of robotic deployment: dull, dirty, and dangerous. And I've been to a lot of facilities like yours, and there's no shortage of all 3 of these categories when it comes to your assets and systems. So today, rapidly maturing technologies like robotics, AI, and machine learning are providing new options for industrial businesses to achieve these critical O&M objectives. Many industries are increasingly turning to remote operated vehicles, or ROVs, to meet O&M targets for reliability, productivity, safety, and cost control. And a new class of industrial ROVs with advanced mobility, sensor capabilities, and high-quality data collection is now providing a really credible solution for O&M requirements. So I'll pause right there. I'm curious, how many of you already have drones in your facilities, or maybe know a third-party inspector that's bringing these tools to your sites? Similarly, some of you are likely familiar with any number of robot crawlers and other task-specific robots that run up and down boiler walls, pipelines, and other hard-to-reach, dangerous places. Well, according to the latest figures from the International Federation of Robotics in 2018, there was a 30% increase in the number of industrial robots shipped over the last year. IFR also states that from 2018 to 2021, global robot installations are estimated to increase by at least 14% on average per year. Your peers are getting on this train, and we hope you will too as well. So robots are now becoming cheaper, more capable, and more widely adopted. But what does this all mean for you? So, well, it comes back to our central theme of increasing safety and efficiency in O&M. Owners and operators, your peers who are looking to decrease downtime costs, they are the ones that are leveraging the capabilities of these latest generation of industrial robots. Again, today's ROVs represent an opportunity to make a significant impact in reducing associated outage costs across several areas. A lot of them are listed here on the slide. So again, if many of you are likely familiar with how drones and other task-specific crawlers can conduct traditional NDT and other types of inspections and are replacing many of the handheld tools that are commonly used. But the important thing to note here is that these robots, they are not replacing humans. They're just simply giving humans a better way to do what they do best. So I want to pause here for a moment. Assuming we can all agree that the above benefits are true, and robotic devices can create all of this positive impact, I'll ask you again, how many of you are already using robots? Maybe more importantly, how many of you are actually using them daily as a planning and qualifying tool for the other O&M decisions you make? One of the main reasons we wanted to host today's webinar is so we can really begin to demystify the challenges associated with using robots as an everyday tool versus just a reactionary tool. Because today, sadly, most robots are only being called into action after something has happened or for any other reactionary reasons. For your sake, we really want to get you out of this mindset. How many of you own a robot in your facility? Have one standing by for deployment at any moment for any number of jobs, tasks, or emergencies you might face daily? How many people on your team do you think can be trained to use a robot successfully? It's likely more than you think. How many of you are waiting until something fails before you decide you need a tool like a robot? Only then to have to call a specialty provider, wait several days before they can arrive on site, and then even pay a large fee for their time in operating a robot in your asset and giving you back your information. What are the costs associated with thinking this way about this type of tool? We, again, want to change that mindset. So I've seen a lot of your facilities. I know your teams work with far more complicated technology every day than a robot. I think it's time we start to change the mindset that robots are hard or require lots of training and certification, because not all of them do. So now, having made that statement, by no means am I diminishing the value of a third-party inspection partner. In fact, quite the opposite. I really highly endorse the value and expertise they bring. What I am suggesting, however, is that there is an incredible amount of value in owning a tool like a robot and having it on site, at the ready, quick to deploy, and easy to train and intuitive to operate. There are options available for that. So just as all downtime is not created equal, well, not all robots are created equal. Sometimes you need a planning tool that allows you to plan for the right tool at the right time later on. Something that can give you a first look and the type of situational awareness data you need to empower you to answer questions like what equipment needs to be sourced next, what specialty personnel are needed, what specialty provider might be needed, how quickly can I really resolve this issue. Which brings us to the Guardian S. Selfishly, this is our unique answer to solving your daily O&M challenges. Now, our robot is not the tool that will solve every challenge you're going to face, but this is not a specialty tool for one type of task. This is a platform tool, and I stress the word platform. So at its core, the Guardian S is a really powerful remote visual inspection robot for a variety of industrial, confined space, and other hazardous inspections. You can see its snake-like form factor allows it to really access spaces that other robots can't. In fact, we can operate in a pipeline of up to 8 inches in diameter. That's how small we can access. So the snake-like robot has 360 degrees of 4K digital cameras. You can see all of that in that front sensor module there above where it says Sarcos Guardian S. There's thermal imaging, and it's intended to have an additional 10 pounds of other task-specific sensors added to it. This could be a LiDAR system. This could be radiation and gas meters, other imaging sensors, UT sensors, you name it. This is, again, a platform. So if you follow that picture all the way to the back of the robot, on top of that radio module and on the side of those rails are where we create options for you to mount those additional task-specific sensors. Again, it's all about giving you the data that you need when you need it. So if you know there's a certain type of information you need to get from an asset, strap on the right sensor, send our robot in, and get it quickly. Something you'll notice, and something we really wanted to bring to the world of crawler robots, is the fact that ours is untethered. It doesn't have a cumbersome spool of fiber optic cable and other heavy things to carry along with it. It can climb metal surfaces. It can crawl and operate in subterranean for up to 3.5 hours on a full charge. Again, another really piece of important value we wanted to give owner-operators like you. We needed you to have a tool that can operate for a long period of time. And if you've experienced some other robots, sometimes this is a big challenge. So we know all of your facilities are different and they present unique communications challenges, which is why our Guardian S is equipped with wireless, LTE, and even dual band radio capabilities, which really allow us to confidently remote operate the robot up to 1,000 feet. So more importantly than anything else, in my opinion, having conducted some of these inspections with this robot, is that it's man portable. I don't know if you saw in that first image when Scott was giving you a bit of information about my bio, but I had the Guardian S draped over my shoulder. In that same image, I had to climb 20 to 30 flights of scaffolding with this thing on my shoulder and the control unit in my backpack, and it was really easy. And it's quick deploy. It can be booted up and operational in under 2 minutes. Again, if you've got a really heavy, cumbersome system that creates additional challenges in getting it to the points in your systems in your facility that you need it to, that's not going to help you in the adoption and ease of use. Again, we want to change that. It takes a lot of time and permitting to get, scheduling for confined space entry. Again, you need a quick deploy, qualifying tool, and you need a tool your team is confident in using. And that does not require certification to use. Again, our goal is to really demystify the challenges of using robots like this. Again, you guys use much more sophisticated equipment on a daily basis. I believe that. So what do I mean when I say the Guardian S is a platform-based ROV? Well, it's a robot that is designed to be sensor agnostic. To stress something brought up in the previous slide, the Guardian S is a multi-purpose robot. So you'll see here in this first image, we've got a multi-ray gas sensor. It's a 5-gas meter. We've got it mounted onto the rear of the radio module in the back of the snake. And that USB port on the top of that other camera module can either both independently power or feed the data from that sensor directly into the robot's control unit. We know a lot of your systems and assets in your facilities are pitch black and have terrible lighting. So again, we wanted to create an opportunity for you to be able to use this robot and create the illumination you need. You can see here I've got a couple flashlights mounted onto a Picatinny rail, and I've even experimented with some what are called Litra torches. They're kind of like lume cubes, and believe me, these things pack a wall of light. The third image you see here, this is a Leica 3D imaging sensor. So again, for 3D mapping and trying to really understand change over time environmental issues in some of your assets, tools like this can be used. So again, part of why we wanted to host today's webinar is to address a gap we see in how your peers have been adopting and utilizing robots. More specifically, task-specific robots intended to provide operators with only one form of data. You should demand more from your robots, and your robot should be able to be tailored to your unique daily challenges. That's why the Guardian S exists. Again, to be clear, I'm not suggesting that task-specific robots are not valuable. In fact, quite the opposite. But again, we want to encourage owner-operators to think and be able to react quickly and respond to a wider range of potential challenges that may occur in your facility. Something that can help you with the situational awareness you need to make better follow-on decisions. I grew up in a military family, and my father's beaten to death to me all about the 7 Ps. Prior, proper planning prevents piss-poor performance. In your facilities, success or failure is defined by your planning and your ability to get in front of issues before they arise. This is how we want you to think about robots. How can they help you plan better? We can't really talk much about the robot without also showing you the control unit that goes along with it. That image to the right is the actual remote control. If you've got a son or daughter or grew up with video games yourself, we wanted to make this as easy and as intuitive as it could be. Give you a really big screen so that you can see in real time all of the information and the data that the robot's giving you. This image to the left is an example of that. This is in one of our offices, and on the bottom you can actually see that multi-ray gas meter from the image before. Its meter readouts are in real time at the bottom of the screen. You can also see to the left of that how strong your radio and Wi-Fi communications with the robot are, so you'll know before you ever lose line of sight and lose control of the unit. You can see to the right how much battery strength you have, making sure you know that you can get the robot back out of your asset, and things like that. So I'm going to use this screen here as just a quick little buffer. I'm going to try to load a quick video for you because it's important for you to see actually how this Guardian S maneuvers. This is really where our robotics expertise comes into play, and it's something that is really impressive. So hold on one second. Let me get this teed up. All right, so you see here something that's really unique to our robot that other ground robots have an issue with is rolling over. The second a robot rolls over, it usually doesn't come back up. Ours doesn't have that challenge. Showed you there a little bit of its arching and its ground clearance capability. It's now climbing a ferrous surface, showing its rollover capabilities. And again, this is what gives us the confidence from being able to say this can enter your asset and actually start to be able to navigate the twists and the turns and the confined spaces that it's intended to. Right there, great snapshot of us going from 0 to 9 degrees on the metal pipe. All right. So we'll close out of that. So now that you've gotten a taste of, what the robot can do, let's really take a look at some of the proof in the pudding here. Ameren, it's a large utility and power generation company in the Midwest that we started working with not long ago. They wish to augment their inspection process for its power plants and its assets by using crawlers for remote visual inspection. Before coming to us, they had explored several other options in the past, and they really hope to improve its maintenance planning and inspection by capturing just better, higher quality visual data that would give an accurate assessment of their boiler's condition. So this data could then be used to streamline the scope of the maintenance and reduce projected asset downtime. So Ameren came to us and they chose the Guardian S to leverage its ability to maneuver in tight spaces, twists and turns, and other complex terrain, all while collecting that same high quality data. The robot completed a successful first look visual inspection of one of their boiler superheaters and waterfall tubes to determine the amount of slag, the location of leaks, and the extent of repairs needed. To date, the company had conducted visual asset inspections manually with inspectors crawling into the drums and headers. They used boroscopes or cameras attached to sticks to capture the images of the assets. And getting an accurate picture of the asset's condition, especially its components at high elevations and in confined spaces, has really just continued to be difficult. And I imagine this may sound very familiar to some of you. So what we did, well, the Guardian S was inserted through a manway in the upper third portion of their boiler, attached to the interior radiant walls by climbing, just as you saw in that last video. And then the operator guided the robot up the slag encrusted walls and surfaces to visually inspect and capture footage of the pendant superheaters hanging from the boiler roof. So this was an example where they didn't need to make use of that additional payload capacity, but if they did, the robot would have been available for them. What they saw was that the lower water wall heaters were similarly inspected. The robot was inserted into the mud drums to access the tube penetrations, and the operator guided the robot inside the header to visually inspect the asset while watching its progress on the control unit screen. The Guardian S was successful in climbing the vertical furnace walls. It traversed across the water wall tubes and in the difficult, unstructured boiler terrain. The robot was able to access the necessary areas in the top of the boiler and the slag buildup on the pendant superheaters, and then also enter the hard-to-reach headers below to inspect for leaks and other material buildup. So more importantly here, what was the result? Well, Ameren confirmed that our robot inspection platform would augment and positively contribute to both planned and forced outage missions through increased employee safety and significant financial savings. So using the Guardian S eliminated the need for employees to enter mud drums, significantly reducing safety risks associated with the inspection. They calculated for us a reduction of 16 to 32 man hours needed to complete the mud drum inspections with the Guardian S. It's a major reduction. What would you do with 16 to 32 additional man hours to do something else? And again, the boiler leak reduced by 2 to 4 days, that inspection. Again, what typically could take 3 to 5 days, with early visibility into potential damages, Ameren had more time now to prepare a better maintenance plan. Again, it's all about that planning. And now understanding how long the unit would be down and purchasing replacement power sooner. So Ameren believes that by being able to make such informed decisions, it can shorten the time boiler units are out of service, and more importantly, help minimize their O&M expenses. So armed with both real-time and post-mission visual data, they can now gauge the extent of damage and repair needed, enabling their teams to optimize their inspections and maintenance, planning with more accurate cost and downtime estimates. Because again, it's all about that planning. So it's pretty clear they believe the ROI for the Guardian S is especially compelling, considering that the robot's multi-purpose platform can be leveraged for many other inspection scenarios across their locations. And after a successful pilot, they purchased one of our robots, and they're now planning to deploy it through other of their locations across the country. Moving on to another one here. This is a familiar name, General Electric. Their risk mitigation team was looking for options to potentially replace the process at one of its facilities of having 2 employees on a scissor lift manually, examine the extraction system ducts. The employees would open hatches in the ducts at 30 to 50 foot increments. They would then reach into the duct and use a flashlight to inspect the current section. As I'm sure you can imagine, the process was lengthy and meant that employees had to be working at significant heights. So GE chose to evaluate the Guardian S, and the objective of the first trial was to determine the levels of dust and debris in 4 of their overhead dust extraction systems, and to plan for material removal. The ductwork involved in the inspection spanned approximately 850 meters. The initial expectation was that there would be very little to no debris in the extraction systems because they'd only been in service for about 2 years. Right now, that's just, they found out they were wrong. The Guardian S was inserted into the duct and made its way through each section, recording 4K video, capturing images with high-definition cameras, and traveling through debris, dust, rough metal edges, and exposed sheet metal screws flawlessly. The robot was able to navigate tight turns and move forward and backward to really give them a comprehensive inspection of their ducts. The data was reviewed in real time, allowing the team to experience the inspection as it took place. As you heard, really unexpected volumes of dust and debris were detected throughout the ducting, despite their relatively short period of operation. And the video and imagery showed the dust debris collecting at the duct seams due to the design of the ductwork. This material was immediately removed. So again, what was the result? Well, GE helped us calculate that a significant reduction in labor hours from 448 to 24 hours was needed to conduct the inspection, which translated to a completed job in a day and a half instead of a week and a half. The typical cumulative manufacturing downtime for them of 8 days was now reduced to 2. In a sense, the robot paid for itself with that one inspection. And the discovery of the root cause of the buildup being the seams in the ductwork is now going to be used to drive updated design criteria for the dust extraction systems that will be implemented in new ductwork installations. So again, a lot of cost savings and benefit there. Won't spend as much time on this one. I think you guys are getting the gist. Another manufacturing facility was scheduled for remediation under the Brownsfield program sponsored by the EPA. The company needed a way to identify both types and quantities of contaminants inside their pollution control systems to assist in the planning for the EPA-regulated remediation. Jumping straight to the results, the inspection was completed in 5 hours, a job, again, that would have taken 2 people, a total of 32 labor hours to complete, all while risking their safety. And the company eliminated the need for humans to enter confined space throughout the planning phase. Samples were collected within the ducting at no risk to the external air quality. Knowing the nature of the contaminants allowed the company to plan precise efforts for remediation that complied with all of the regulatory requirements. And in addition, the company saved the potential travel and processing costs associated with additional trips to the hazardous disposal facility. So at this point, you're getting an idea of all of the range of versatility that this type of robot can offer you. But let's recap a little bit. So standard maintenance practices are labor intensive and inefficient. I think we can all agree there. Our common goal for all of you is likely to operate with the leanest staff and the limited labor waste and the fewest safety incidents. Again, all of that's efficiency and cost savings. Industrial companies like yours are now able to significantly improve workforce performance, productivity, and safety through smarter maintenance strategies that include modern automation technologies, robotic sensors, platforms, and other data analytics and cloud computing. So the net result is improved insight into your process and equipment conditions. You, as managers, are now empowered to make better informed business decisions in the field and on the plant floor. And this can only happen if you have the right tools that help you plan better. Again, we believe our robot is the exact type of tool that can really aid in this. And so across power gen, oil and gas, manufacturing, and other industrial entities that have implemented preventative maintenance and other labor-saving automation technologies like this, they've experienced a productivity gain among maintenance staff of up to 66% and process efficiency gains of 20 to 30%. And we want that for you. We want you to have that kind of cost savings and efficiencies. And so with that, we're going to open it up to some Q&A. The best way to experience this and learn if this is the right system for you is to request for one of us to come on site, show you our robot live in action, and really prove to you what it's capable of. And we want that opportunity. So after all is said and done today, if that's something you're interested in, give us a call, give us an email, and we'd be really happy to talk to you. So for now, I'm going to turn it back over to one of my moderators to help me understand what questions are coming in, and we can start to answer some of those for you. So we've got this first one. Is your product waterproof? The answer is yes. We are technically IP65 rated, which means that we can operate in up to 3 to 4 inches of standing water safely without any ingress into the robot or its systems. It also means that we can safely decontaminate the robot after any number of uses. I've had to hose mine off any number of times, and we are starting to work with partners that if you are working with truly chemical and other hazardous materials, they're going to be able to help us decontaminate the robot for you and get your robot back and operational for you. Let's see this next one. For the black 3360, seems like it would be a little top heavy. Does it have a tendency to roll? That's a great question, Jarvis. So in the system, as part of our design, we've created inertial sensors in the form of a sort of anti-roll capability, specifically for when we have payloads mounted on the back. I'd love to show you this at another time, but you can actually physically try to flip the robot over and visibly see it fight itself back to stability. Something you didn't get to see is we can also stagger the stance of the robot in a couple different ways to spread out its weight distribution, so that when we are traveling on uneven terrain, we can create as much stability as possible. But to sort of round this all off, again, what we feel makes our robot really unique that other ground robots struggle with is that there's stability with the instability of the platform, if you will. Our robot is intended to be able to roll itself over and right itself back up. And that is something we think is really valuable because if you've worked with robots before, this happens. Jarvis will answer another one of your questions. Can you do tank inspections? The answer is yes. We'd certainly love to know more about the details of the specific inspection you're wanting us to do. But yes, that's something we've done successfully for a lot of others. I see one here from Mikey Henderson. Give me a second to read this real quick. All right, so your question is about storing data and being able to run time and how it might affect the runtime of the robot in terms of storage capacity. So the robot right now is streaming data back to the control unit in real time. It can be stored there and offloaded after for post-mission review. We're even doing some really cool things where we can start to record images from all 5 of our cameras on the robot, start to stitch all of that together, and even in a post-mission review, give you guys a bit of a 360-degree, unobstructed view of the mission you just went through. So hopefully, it seems like there's a bit more. We're going to move on to Taylor Duncan here. It's what type of structural testing has the Guardian S successfully survived, especially for jobs at dangerous heights? What information could you share about the integrity of the structure and the replacement, repair, and servicing of the robot? Taylor, that's a really great question. What you didn't see in one of the images was a safety tether hook. So specifically when our customers have the robot operating at heights, We do always recommend that a safety tether is attached, so that in the event the robot does lose, grip on whatever it's climbing, this 17-pound machine doesn't just come crashing down to the floor. More specifically, though, it has been drop tested very thoroughly. This is a really ruggedized military-grade device. It can fall from about 5 feet repetitively with no real internal damage of the robot. And so, those are some of the things that we feel pretty confident make this a really, ruggedized, durable platform for you. But to that end, again, if you've used robots, they break. It's inevitable. Our staff in Salt Lake City is exceptionally well trained to repair, maintain, and support the robot and get it back to you as quickly as possible. We've seen this with some of our competitors. A lot of time, little bits of damage tend to total the robot. What we've seen through some of our early deployments is that we can repair things pretty cost effectively so that you as the owner aren't really hit with that. And the warranty that we offer with our robot should go a long way in offering that. This one's from Brian Wilson. Can you take dust and solid samples inside a space? The answer is yes. In one of those last use case examples, we had rigged a system off of the Picatinny rails on the side of the robot that were intended to hit the surface of what the robot was climbing over. And that was how we were able to scoop up and actually gather samples and solids for that company. Again, they wanted to be able to identify what types and what quantities of material were in their pollution and extraction systems. And that was one of the ways we were able to do that. This one comes from John and James. What is the expected lifespan of the Guardian S? It's a great question. I don't think we know fully. We started to deliver to our first customers around the middle of last year. I think as part of the answer to the previous question, we've seen a few of those robots come back with just routine calibrations and other maintenance. And again, all of those repairs were done successfully, and we were able to get the robot back in use very quickly. The robot does come with a 1-year warranty, but we're pretty confident that it's going to have a much longer lifespan than just that. This one comes from Marcel. The question is, what is the delivery time or the delivery term? Right now, there's about a 10 to 12 week lead time. We've got a lot of demand from a lot of customers. So right now, we're pumping out as many robots out of Salt Lake as we can. But yeah, you're looking at about 10 to 12 week lead time before we would be able to deliver a robot to you. This one comes from Brian again. It's capable to climb an external tank wall and take UT thickness readings. So yes, it can climb the external tank wall. We have done some testing with a dry couple UT sensor that seemed to work pretty well. Personally, I've not done enough of that type of work to say whether that would be a bulletproof use case. But it's a great question, and if you're open to it, we'd love a chance to come down and work with you and see if we can prove that. This one comes from Mike. Does it move across sand? And the answer is yes. The tank tracks and a lot of the general dexterous mobility we've given the robot creates a lot of that opportunity. As a bit of history, the robot was designed with our U.S. military and other DoD forces in mind for mining and other hard to reach navigational areas. And so sand is definitely one of them. This one comes from an unnamed attendee, but how long approximately the robot can operate after one fully charged? In case you missed this point earlier, this is about a 3.5 hour operational time on a full charge. The robot has 5 lithium batteries, 2 that are hot swappable within the control unit. Yeah, again, it takes about 3 hours to charge all 5 of them, but you get about 3.5 hours of full life out of them. This one comes from Marcel. Are you ATEX certified? So I believe ATEX is the European directives for controlling explosive atmospheres. The answer to that is no, not currently. In the United States, we do not meet intrinsic safety or Division 1, Class 1 requirements. I will say this, loosely, but I don't know of many robots who can say that confidently. It is a priority of us to continue to explore how we can make our systems meet some of these certifications, but as it stands today, it is not something we can offer. And I think that might have been all of the questions that I've seen that come in. So maybe we'll leave it here today. Again, thank you all of us. Thank you all of you for attending. It means a lot to us that you're here to learn about what our robot's capable of. Again, we'd really love an opportunity to come visit you on your site, find a way to prove that our robots can meet what you're looking for them to do. And so we'd love to hear from you. If there's anybody who has questions after the fact, please email us or send an inquiry through our website. We want to make sure to address all of your questions. So,
yeah, thank you, James. And if you're done, I'll go ahead and wrap up here. And thank you, everyone, for attending today's webinar, How to Improve O&M Safety and Efficiency with Remote Inspection Robots. It looks like we got to most of the questions, but if you have additional ones, feel free to reach out via the contact, and we'll have somebody give you a call or reach out via email. Again, should you have any other questions now or ever, we're all here to help, and you'll also receive a follow-up email next week with a link to view the recording of today's webinar. On behalf of everyone at Sarcos Robotics, thank you for joining us today, and have a great rest of your day.